Hello, in this lesson, I want you to identify and use medians in a triangle and identify and use altitudes in a triangle. Some vocabulary you're going to come across is median, centroid, altitude, and orthocenter. We'll get started here with a median. A median is a segment that connects the vertex to the midpoint of the opposite side. See how it bisects that opposite side? We don't care about the angle, but it connects the midpoint of one segment to the vertex of the opposite side. The point of concurrency, where all three lines intersect, that's called the centroid. This is the true balancing point of your triangle. That is, if I would cut this triangle out and I would place my pencil point where the centroid is, it would actually balance my triangle on the pencil point at that right there. Now, the centroid theorem says the point of concurrency is 2/3 of the length from the vertex. So if I look at this, B to P is 2/3 of the length of B to L, or P to L is 1/3 of the length. A lot of times we say it's in a ratio of 2 to 1. And that's what I want you to remember. It's in a ratio of 2 to 1. It's not the center. It's in a ratio of 2 to 1. If we take a look at example 1 here, it says in triangle XYZ, P is a centroid and Y to V is 12. So here's what I'm going to do. I'm going to label Y to V as 12. Make it a little bit thinner here first. And then, since I know P to V is 1/3 of that, 1/3 of 12 is 4. 2/3 of 12 is 8. 4 plus 8 is 12. And then we can answer the question. Find Y to P. I think we've already answered it, haven't we? So Y to P is 8. And P to V is 4. They have a ratio of 2 to 1. If we take a look at example 2, we're told C to G is 4. So I'm going to label C to G as 4, which means this is twice as big as G to E. So G to E is 2. And C to E would be 4 plus 2, which is 6. And we're supposed to find G to E on this one. That's the only thing they asked us to find. So G to E is 2. And that's all you would have to do in a question like that.